Welcome to ST.SEBASTIAN Pre-University College. Namaste students. In this video, I am going to explain empirical formula and molecular formula. Now, what is empirical formula and molecular formula? Here, I have written the definition, empirical formula. Empirical formula I have written in the form of EF. Okay. Empirical formula gives the simplest whole number ratio of atoms of different elements present in a compound. I will repeat. Empirical formula gives the simplest whole number ratio. Gives simplest whole number ratio of atoms of different elements present in a compound. Now molecular formula. Molecular formula means it is nothing but a exact number or actual number of atoms of different elements present in a compound. Exact number or actual number of atoms of different elements present in a compound. Now this is a definition. Now I will give few examples to understand more clearly about a molecular formula and empirical formula. Okay. Now as you know that, what is the formula of ethane? Ethane, molecular formula of ethane. This you already studied in your lower class. Directly I will write C2H6. Okay. Now this is a molecular formula of ethane. Now, what is the empirical formula? How to write empirical formula of formula for ethane? Okay. Now it is the definition is given as it is nothing but a simplest whole number ratio. Simplest whole number ratio. That means C and H. What is the ratio of C and H in this? Just now in this I will write C here, C1, H3. That means this number. Now in this which is the smallest number? That is the 2. Okay. So 2 has to be divided by this number has to be divided by 2. So 2 ones are 2, 2 threes are 6. So this is a empirical formula. Okay. Now few more examples I will give you so that you can understand more clearly. Now this is about ethane. Now what is the formula for glucose? Glucose I will write glucose. So formula is C6H12O6. C6H12O6. Now this is a molecular formula. Exact number of atoms. See here. Exact number or actual number of atoms of different elements. Atoms of different elements present in a compound. I hope you understood what is the meaning of molecular formula. I will repeat it again. Molecular formula means it is nothing but a exact number. Now glucose means there should be a 6 carbon atom, 12 hydrogen atom and 6 oxygen atom. Okay, it is fixed. So that's why we are saying that molecular formula means it is nothing but a exact number of atoms of different elements. Now what is the meaning of different elements? See, carbon is there, hydrogen is there, oxygen is there. So all these are atom, but atom of different element. Okay. So exact number of atoms of different elements present in a compound. Okay. This is about the definition of molecular formula. Now here I have taken example as a glucose C6H12O6. Now if I want to write empirical formula for this glucose, so how I should write? C is 2. H is 2, O, that means carbon is 2, H, hydrogen is 2, oxygen. Okay. Now here it is given. Empirical formula means it is nothing but a simplest whole number ratio. Now what is a whole number ratio of this? So this number has to be divided by 6. Okay, because in this 6 is the smallest number. Okay, so 6 ones are 6, 6 twos are 12, 6 ones are 6. That means like this you should do if you want to find empirical formula. So what is the answer you will get? C1H2O1. This is the empirical formula of glucose. Okay. Now one more example I will give you, that is about butane. butane. So what is the formula of butane? C4H10. Okay, so exact number of atoms. So exact number of atoms of different elements. Exact number of atoms of different elements present in a compound. So this is the molecular formula. Now empirical formula, what I should write? That is, I have to find out what is the simplest ratio of this. So what is the simplest ratio of this? So this is both the number is divided by which one? 2. Okay, so 2 2s are 4, 2 5s are 10. Okay, so this is a simplest ratio. So simplest ratio, it is nothing but a empirical formula. Okay, so I hope you understood the concept of molecular formula and empirical formula. Now how it is related? Empirical formula and molecular formula, how related to each other? See, I will repeat those examples which have given to explain molecular formula and empirical formula. Previous part I have taken as ethane, okay, and empirical formula. What is empirical formula of this? It is a C1H3. Okay, so one more example I have given as glucose, C6H12O6. What is the empirical formula of glucose? That is C1H2O1. Okay, now just see this. Okay, now what I will do, just I will put is equal to sign. Now if I want to find molecular formula from empirical formula, what I should do? This is multiplied by, this number is multiplied by, if I multiply it by 2, then I will get this answer. 2 1s are 2, 2 3s are 6. Am I correct? Okay, fine. Now here, if I want to find molecular formula of glucose with the help of empirical formula, now what I should do? This is multiplied by which number? 6 number. So 6 1s are 6, 6 2s are 12, 6 1s are 6. You will get the answer. Same thing if I want to write it about this one, what butane. So what I should write? It is a C2H5. So this is multiplied by 2. Okay, so 2 2s are 4, 2 5s are 10. See, you can see how it is related. Molecular formula and this number, that means it is empirical formula should be multiplied by one number. Okay, empirical formula should be multiplied by any one number, so that you will get which one? Molecular formula. Okay, so here number varies. In the first example what I have taken, that is n value of this value, it is 2. Here it is 6, it is 2 again. So if I take different examples, this value, it varies. Okay, so how I can relate? So just I will write the relationship based on this. Okay, based on these I will write the relationship. Molecular formula is equal to, here I will write n multiplication, and here I will write n. In this number, in the place of these number, I will write n. So what is a relation between empirical formula and molecular formula? Molecular formula is equal to n into empirical formula. I hope you understood the concept. Okay, this relation is very important to calculate empirical formula as well as a molecular formula. Now in the next I will explain how to calculate empirical formula and molecular formula based on the question. See, here I have given the question as a compound contains 4.07% hydrogen, 24.25% carbon and 71.75% chlorine. Its molecular mass is 99.03 gram. What are its empirical and molecular formula? Same problem, it is already explained or given in notes also. Here I will explain how it is calculated. Okay, so I will repeat the question. A compound contains 4.07% hydrogen, 24.25% carbon and 71.75% chlorine. Its molecular mass is 99.03 gram. What are its empirical and molecular formula? Okay, now see the way of calculation. So for the first you have to put here I will keep it. Okay. Now first you have to put like this a column. Now here I will write first element. Okay, element I will write. Then percentage is given. Okay. After that for me atomic mass is required. So atomic mass I will write. Okay. Now there is one formula, that is percentage divided by atomic mass. Percentage divided by atomic mass. Okay. Now here simplest number I will write. Simplest number. Then here whole number ratio. Okay, simplest number and whole number ratio. So see, you have to draw column, a table. Okay, now in the first column you should write element. In the second column write percentage. Third column atomic mass. Fourth column percentage divided by atomic mass. Fifth simplest number, and sixth whole number ratio. Okay, so I hope you understood how to draw the column, how to arrange all these things. Now according to the question, here it is given. What are the elements are given in the question? A compound contains 4.07% hydrogen, 24.25% carbon and 71.75% chlorine. Okay, so that means hydrogen is given, then carbon is given, then after that chlorine is given. Okay, so what is the percentage of hydrogen is given according to the question? Again I will read out. Compound contains 4.07% hydrogen. That means percentage of hydrogen is 4.07, and 24.25% carbon is given. That means carbon 24.25. Okay, so chlorine, how much? Chlorine is given as 71.75%. Okay, okay, fine. Now this much information is given in the question. Okay, this much information is given in the question. Now this I will keep it aside, question. Okay, now we'll work out. Here I will keep it. Now atomic mass of hydrogen, this you should know. Okay, so hydrogen atomic mass is 1, carbon atomic mass is 12, chlorine atomic mass is 35.5. Okay, so atomic mass of hydrogen is 1, carbon is 12 and chlorine is 35.1. Now substitute. What is the formula I have here written here? Percentage divided by atomic mass. Okay, so 4.07 divided by 1. What is the answer you will get? Of course, your answer is 4.07. Okay, 4.07. Now here, next one, that is percentage of carbon is given as 24.25. What is the atomic mass of carbon? It is 12. So what is the answer you will get? 24.25. With the help of calculator, do the calculation. So what is the answer you will get? Have you tried? Okay, so answer is 2.020. Okay, so after point how many digits you should write? 4 digits you should write. So I will write one more, 2.0208. Okay, this is the answer. Next, for the chlorine, what is the percentage of chlorine is given? That is 71.75 divided by, what is the atomic mass? 35.5. Okay, now same thing, what you should do with the help of calculator, calculate 71.75 divided by 35.5. What is the answer you will get? I think you trying now. Okay, so answer is 2.021 1. So after point, how many digits you should write? 4 digits you should write. Okay. Now, I hope you understood these. First, what you should write? Element. That element is given. Elements are given in the question itself. Even percentage of element are also given in the question. This you have to remember, atomic mass. Okay. Then next formula, you have to apply percentage divided by atomic mass. Next, simplest number. Now, what is the meaning of simplest number? Okay, what is the meaning of simplest number? See the answers of these three: 4.07, 2.0208, 2.0211. Now, out of these three, which one is the smallest number? Okay, here instead of writing simplest number, do one thing, write as the smallest number. Okay, so it becomes more clear. Smallest. So smallest number. This is enough. Smallest number. So among three, 4.07, 2.0208, 2.0211. Now out of three, which one is the smallest number? 4.07, of course it is a bigger one. Okay, here there is a confusion between these two numbers, isn't it? So 2.02 up to 2.02, it is the same. Okay, it is same. But where it differ? So here it is 0, here it is a 1. So which one is the smallest number? That means 2.0208 is the smallest number. So each answer should be divided by, okay, listen properly, each answers, these are the answers, each answers should be divided by a smallest number. So which one I have selected as a smallest number? 2.0208. This is the smallest number. So what is the answer you will get? Each this one answer should be divided by a smallest number. So here I have written 4.07 divided by 2.0208. So what is the answer you will get with the help of calculator? So you should do 4.07 divided by 2.0208. So what is the answer? 2. So here I will write, okay, 2.0140. Okay, so draw the column little big. Here I will just turn this. Okay, there is no space, that's why. So okay, fine. Now, so 2.0140. Okay, next same thing. Here also you have to do it. 2.0208, which is the smallest number I have selected. That number itself, it is the smallest number. So what is the answer? You will get 1. Okay. So here third, 2.0211. What is the smallest number? 2.0208. What is the answer you will get? Of course, since it is the same, your answer is in the form of 1 only. Okay. So it is a calculate and write down the answer. What is the answer you will get? It is there is no space. So here 1.0001 you will get. So after point, how many digits you should write? 4 digits you should write. So it is a 1.0001. Okay. Now what is the next column? That is simplest. Sorry, it is a whole number ratio. Okay, it is a whole number ratio. Now how to find out whole number ratio? Now here this you have to digits you should convert into or convert into a whole number. Okay, so 2.0140. Now 2.01 I can write 2 itself. Okay, you can round off the figure. Okay, so this anyway it is in the whole number. Okay, and this is also considered as a 1. Okay, so whole number ratio is 2, 1, 1. Okay. Now, here. So, what is the empirical formula? Now, this is the empirical formula. Empirical formula of this element. So, I will write hydrogen, carbon and chlorine. Hydrogen, carbon and chlorine. Hydrogen, what is the ratio for hydrogen? You got 2. Final answer is 2. What is the ratio for this? It is a 1. Chlorine, it is a 1. Okay. So, empirical formula of these element is H2, C1 and Cl1. Okay. Now, how molecular formula? Now, what is the question is asked? Question is asked as what are its empirical and molecular formula? Now, empirical formula is finished. Calculating empirical formula is finished. Okay. Now, I am going to calculate molecular formula. Now, molecular formula and empirical formula, how it is related? That is, molecular formula is equal to N into empirical formula. This is a formula. So, I will repeat it. How it is related. That is, molecular formula is equal to N into empirical formula. So, here, now, empirical formula, here I can write as H2, C1, Cl1. Okay. Now, what is the N? I don't know N. So, there is, once again, there is a formula to calculate N. So, N is equal to molecular mass, or I can call it as molar mass or molecular mass divided by empirical mass. Okay, empirical mass. So, this is a formula. N is equal to molar mass divided by empirical mass. Now, here, molar mass is given in the question here. So, here only it is given. Its molar mass is 99.03 gram. Okay. So, in the place of molar mass, I will substitute 99.03 gram. Now, in the place of empirical mass is not given, but we can calculate empirical mass. Okay. See, with the help of this formula, we can calculate empirical mass. How to calculate empirical mass? Now, here I will do it at the side. Okay. So, empirical mass. It is similar to molecular mass itself, how usually we are calculating. Okay. So, empirical formula I will write first. That here we already calculated. Now, how many hydrogen atoms are present? 2. What is the atomic mass of hydrogen? 1. Since I am going to the next element, I am writing plus. How many carbon atom is present? 1 into 12. Atomic mass of carbon is 12 plus. What is how many number of chlorine atom is present? 1 into 35.5. Okay. So, what is the answer you will get? Calculate. Okay. Now, what is the answer you will get? That is 2 ones are 2 plus 12 plus 35.5. So, calculate. Okay. With the help of calculator, you can calculate easily and write down the answer. So, what is the total answer you will get? 49.5. 49.5. I hope you understood how to calculate empirical mass. Okay. So, here I will substitute 49.5. So, what is the answer you will get? Okay. So, that is with the help of a calculator, calculate and write it down. What is the answer you will get? 99.03 divided by 49.5, that is equal to 2.000 okay 6. So this is the answer. N value Now since it is in a decimal point, again we have to convert into a whole number. Okay, so this is considered as a 2. This is considered as a 2. Okay, now n is equal to 2. Now easily we can calculate molecular formula. Okay, here, so here molecular formula is equal to n into empirical formula. N value, how much we got? N value, that is a 2. So here I will substitute n value, that is a 2. So what is the molecular formula we will get as? So number you should multiply. Hydrogen, 2 2s are 4. Okay, this part I will erase so that you can see more clearly. That is, molecular formula is equal to 2 2s are, hydrogen. First I will write the element. Okay, so 2 2s are 4, 2 1s are 2, 2 1s are 2. So this is the molecular formula. I hope you understood how to calculate a empirical formula and a molecular formula. This type of question is very important for the exam. Usually this type of question is asked for 4 marks. Okay, it is a fill 4 marks. Easily you can score fill 4 marks. Now, next, second problem. Here, see, find the empirical and molecular formula for the compound which contains 51.28%, 9.40%, 27.35% and 11.97% of carbon, hydrogen, oxygen and nitrogen respectively. Okay, molar mass of the compound is 234 gram per mole and atomic masses of these elements are given. Carbon is equal to 12, hydrogen is equal to 1, oxygen is equal to 16, nitrogen is equal to 14. Okay, so you can see the question properly. Percentage of carbon, hydrogen, oxygen and nitrogen is given. Okay, now I have already drew the diagram, column, a table. Okay, so what are the elements are given? So here I will keep it the question. Now what are the elements? That is carbon, so I will write carbon. Okay, next is given as hydrogen, then next is given as oxygen and next is given as nitrogen. Okay, carbon, hydrogen, oxygen and nitrogen is given. Now what is the percentage of these elements according to the question? So 51.28% of which one? That is carbon. Okay, so 51.28% of carbon. Okay, so 51.28, then 9.40% of which one? Hydrogen. So 9.40. Now 27.35% of which one? It is oxygen. So 27.35. Okay, then nitrogen, it is 11.97. I hope you understood. Okay, element, name of the element and percentage is given in the question. Okay, now atomic mass. Atomic mass, carbon 12, hydrogen is 1, oxygen is 16, nitrogen is 14. Now in this problem, atomic masses of following elements are given, but you should know the atomic masses of a few elements which is given in the notes book. Okay, at least you should know that one. Now here, next part, percentage by atomic mass. Now, what is the percentage of atomic mass? Sorry, percentage by atomic mass. Now here, percentage of carbon, it is given as 51.28. This I will keep it aside. 51.28 divided by 12. Okay, so take out your calculator and calculate the simplify the problem. 51.28 divided by 12. So what is the answer you will get? As a, here I will write 4.5 1.2733. Okay, after point, how many digits you should write? 4 digits you should write. The next, so what is the next one? 9 point percentage of hydrogen, 9.40 divided by 1. So answer is 9.40. Next it is 27.35 divided by, what is atomic mass of oxygen? It is 16. So what is the answer you will get? Calculate. Okay, so 27.35 divided by 16. Answer is 1.7093. Okay, 1.7093. Now next, what is the percentage of nitrogen? It is given as 11.97 divided by, what is atomic mass of nitrogen? It is 14. So do the calculation. 11.97 divided by 14. So what is the answer you will get? That is 0.8550. Okay, so after point, how many digits should be there? 4 digits should be there. Okay, now these are the answers: 4.2733, 9.40, 1.7093, 0.8550. Okay, now what is the next column? Next column, it is written as smallest number. That means out of 4 value, okay, you have to select a smallest number. So which one is a smallest number? It is a, see here. So which one is the smallest number? That is 0.855 is the smallest number. So what you should do? Each answer is divided by which one? Smallest number, that is 0.8550. Okay, what is the answer you will get? 4.2733 divided by 0.8550. Okay, now do it by yourself. So what is the answer you will get as a so here I will write there is no space in this column. Okay, so what is the answer? It is 4.9980. Okay, 4.9980. Now next, here 9.40, smallest number is 0.8550. So what is the answer you will get? Do it fast. Okay, before writing my answer, you should finish it off writing your answer. So what is the answer you will get? 9.40 divided by 0.8550. Answer is 10.994. Okay, now what is the next? Here, so here 10.9941. Okay, so because after point, how many digits? 4 digits. So next one is 1.7093 divided by 0.8556. So what is the answer you will get? 1.7093 divided by 0.8550. So answer is 1.9998. 1.9998. Okay. So here 0.8550, see this is number is divided by same number. So answer is 1. Okay. Now whole number. How to convert into a whole number? 4.99. So this is considered as a 5. 10.9941. So this is considered as a 11. 1.999. So this is considered as a next number as a 2. This is a 1. Okay. Now this part I will explain now. Here I will explain 4.9980. Now this number you have to convert into a whole number as, okay, now whenever, just I will write, this is just example 4.1, okay, so 4.2, 4.3, 4.4, 4.5, 4.6, 4.7, 4.8, then here I will write 4.9. Only these, after point only one digit I have written. Okay. Now 4.1 is considered as 4 itself. 4.2 is considered as 4 itself again. 4.3 it is also considered as 4 only. Okay. 4.4 it is considered as 4. But 4.5 it is considered as 5. It is considered as 5. That means after decimal point, if number is starts from 5 to 9, then you have to convert previous number into a next round figure. Okay, I will repeat. If decimal point contains 0.5 up to 0.9, okay, then this number, okay, this number is converted into a next round figure. So what is the next round figure of 4? It is a 5. So here also same thing, 4.6. So here it is considered as a 5. Okay, 4.7, again this is also considered as a 5. 4.8, this is also considered as a 5. 4.9, this is also considered as a 5. I hope you understood. So based on the concept, here I have written as a 5. Again here 10 point. So this entire number, it is converted as a, or considered as a whole number as a 5. Okay. Now one more number is given, this. Okay, 10.9941. This is have considered as a, next whole number is 11. Why? Because see here, it is a more than, it comes under this category. Whenever 0.5 number, that is from 0.5 to 0.9, okay, then this first number can be converted into a next whole number, can be converted into a next whole number. So what is the next number of 10? It is 11. Okay. So same way 1.9. So this is also considered as a 2 because it is a 0.9 is present. Okay. Then here anyway this is whole number itself. So it is written as a 1. Okay. Now so based on this, I hope you understood how it should be converted into a whole number. Now what is the empirical formula? Empirical formula. So what are the elements present? Here carbon, hydrogen, oxygen, nitrogen. In that order only I will write so that you can write number easily. Carbon, what is the answer you got? Whole number as 5. Here I will write below. Hydrogen, what is the answer you got? 11. Oxygen, it is 2. Nitrogen, it is 1. Okay. So empirical formula is C5, H11, O2, N1. Okay. So next, what is the next step? You have to calculate a molecular formula. What is the relationship between molecular formula and empirical formula? That is, molecular formula is equal to N into empirical formula. Okay. So here N I don't know. Empirical formula it is already calculated. C5, H11, O2, N1. Okay. Now, how to calculate N? So here molecular formula is equal to N. Okay. So N, what is the formula of N? That is molar mass divided by empirical mass. Okay, N is equal to molar mass divided by empirical mass. Now molar mass, it is already given in the question. What is that? Molar mass, here it is given. Molar mass of the compound is 234 gram per mole. 234 gram per mole. So in the place of molar mass, I will substitute 234. Okay. Now, next, which one it is required? Empirical mass. How to calculate empirical mass? Here I will show how to calculate empirical mass. That is C5. What is empirical formula? C5H11O2N1. So how many carbon atom is present? 5 into atomic mass of carbon is 12 plus hydrogen 11. How many hydrogen atom? 11 into 1 plus how many oxygen atom? 2 into 16 plus nitrogen, 1 nitrogen atom into 14. Atomic mass of nitrogen atom is 14. So 5 12s are 60, 11 ones are 11, okay, 12 16s are 32 plus 1 14s are 14. Okay, if you add these number, what is the answer you will get? It is 1 2 okay, fine, 117 you will get, 117. Okay, this is a empirical mass. 117 is empirical mass. So here I will substitute this. So what is the answer you will get? 234 divided by 117. That is, it is 1 2 okay, 2. Answer is 2. You will get answer as a 2. Okay. So I got value N as a 2. Now I will substitute to this. Okay. So I will erase this part. So what is the value of N I got? That is, N is equal to 2 into C5H11O2N1. So what is the answer? 2 5s are. So first I will write the element. Okay. 2 5s are 10. 2 11s are 22. 2 2s are 4. 2 1s are 2. So molecular formula is this. Okay, empirical formula is this. I hope you understood the concept. Now, third problem. Find the empirical and molecular formula for the compound which contain 33.18% carbon, 4.60% hydrogen, 29.49% oxygen and rest of chlorine. So that means percentage of chlorine is not given. Okay. Molar mass of the compound is 108.5 gram per mole. Atomic masses of the following elements given in the bracket. Okay. Now here, so there is a slight change compared to the previous part. That is, rest of chlorine it is given. That means chlorine percentage is not given. We have to calculate chlorine percentage. Okay. Once you calculate chlorine percentage of chlorine, then it is as it is. Okay. So I will show how to calculate percentage of chlorine. Okay. So first what you should do. Now since it is given in the form of a percentage. So total percentage means what is the number of total percentage usually we are considering. It is nothing but 100. Okay. So here I will write total percent of what are the elements given. Carbon is given. Since it is a total, I have to write as a plus sign. Okay, hydrogen is given, then oxygen is given, and rest of the element is called as a chlorine. Okay. Now here total percentage means we have to consider as 100. Carbon, what is the carbon percentage is given? Carbon is 33.18. Hydrogen is given as 4.60. Oxygen is given as 29.49. Chlorine, I don't know. It is rest of chlorine is given. So chlorine we have to calculate. So this is a method of calculation. So what is the answer you will get? 33.188. I think it is 60 67.27. Okay, add this plus Cl, chlorine, here 100. So how to calculate percentage of chlorine? 100 minus 67.27. So what is the answer you will get? As 373. Okay, 32.73. So percentage of chlorine is 32.73. Then as usual, you have to continue the calculation. I will not do, consider this as a homework, okay, and complete the homework. So I will repeat the question, you can write it down. Find the empirical and molecular formula for the compound which contain 33.18% carbon, 4.60% hydrogen, 29.49% oxygen and rest of chlorine. Molar mass of the compound is 108.5 gram per mole. Atomic masses: carbon is equal to 12, hydrogen is equal to 1, oxygen is equal to 16, chlorine is equal to 35.5. Okay, next topic is stoichiometry. Okay, stoichiometry and stoichiometric calculation. Now here, what is the meaning of stoichiometry? Stoichiometry, it is nothing but a branch of chemistry which deals with the relative quantities of reactant and product in a chemical reaction. Relative quantities. Quantities means it is nothing but a number. Quantities of a reactant and product in a chemical reaction. Now, what is the meaning of relative quantities of reactant and product? Okay, that means, suppose if I want to write a equation, nitrogen, okay, nitrogen, when it reacts with hydrogen, it gives ammonia, okay, it gives ammonia as a product. So, reactant and product. Now, here, relative quantities. What is the meaning of relative quantities of reactant and product? That means this is a reactant side. Okay, this is a product side. Okay, now here, how many nitrogen atom is present in the reactant side? 2. But in the product side, how many nitrogen is present in this? Only 1. That means it is not balanced. Okay, here hydrogen is 2 atoms are present. In the product side hydrogen there are 3. Okay, so it is not balanced. So you have to balance the equation. You have to balance the equation. Okay, so first I will see this nitrogen. How many nitrogen atoms are present in this reactant side? 2. So based on that I will write 2 here. So at present nitrogen is balanced. At present nitrogen is balanced. But what about hydrogen? Hydrogen, now it is 2 3s are 6. But here only 2 is present. So here I will write 3. Okay, now 3 2s are 6. Now we'll cross check again. Nitrogen 2 here. So here also 2. That means nitrogen is balanced. Hydrogen is 3 2s are 6. 6 hydrogen atoms are present. Here 2 3s are 6. Again 6 hydrogen atoms are present. So that means on reactant side as well as product side, number of atoms are balanced. Number of atoms are balanced. So this is called as a stoichiometry. This is called as a stoichiometry. That is a relative quantities of reactant. So what are the relative quantities of reactant? That is 1:3. This is number is not there, but it is understood as 1:3. Okay. And what is the quantity of product? That is 2. Okay, so relative quantities of reactant and product in a chemical reactions. So this is the entire concept of stoichiometry, and this is also called as a balanced chemical equation. So what is the meaning of balanced chemical equation? It is nothing but a number of atoms of each element. Okay, number of atoms of each element on both the sides should be equal. Okay, number of atoms of the elements, different elements, okay, on both the sides. On both the sides means reactant as well as product should be equal. This is called as a balanced chemical equation. So balanced chemical equation. So here a number of atoms of each element on both the sides should be same. Okay, number of atoms of each element on both the side should be same. Okay, should be same. So this is a balanced chemical equation. And while writing the balanced chemical equation, we should write physical state of the reactant as well as a product. Physical state. Now what is the meaning of physical state? That means reactant are whether in a solid state or liquid state or gaseous state. Now nitrogen, hydrogen, it is always in the gaseous state. So in the inside the bracket I will write as a G. G means it is understood as a gaseous. Ammonia is also in a gaseous state. If it is in a solid state, I will write small letter S. If it is in a liquid state, either I can write L or I can write aqueous, AQ. Okay, so this is about a balanced chemical equation. Now, based on the stoichiometry, I'm going to do a few problems. These problems are very important for the sake of exam. Okay, before calculating the problems, just I will give a few more information about balanced chemical equation. Okay, how to write a equation. Example, suppose a question is asked, write a equation for combustion of methane. Write a equation for combustion of methane. Now how it should be written. Okay, now what is the meaning of combustion? What is the meaning of combustion? Combustion means it is nothing but a burning. Okay, burning with what? Burning with air. Air means usually we are taking as a oxygen gas. Combustion means it is nothing but a burning with what? Burning with air. That means it is nothing but a oxygen, O2. Okay, so combustion of which one it is given? Methane. So what is the meaning of this combustion of methane? Combustion of methane means methane, it is usually in the form of gaseous state. Methane burnt, it is understood, that means burnt with the air. That is a O2. Okay, oxygen, burnt with the air. So what is the meaning of combustion of methane? It is nothing but a methane burnt with the air. Suppose question is asked as combustion of ethane. What is the meaning of combustion of ethane? It is a ethane burnt with the which one? Burnt with the oxygen. Okay, so combustion of methane means it is nothing but a burning with air or methane burnt with the air or burnt with the oxygen. Okay, now how to write the equation for this sentence, that is combustion of methane. Now methane, you know the formula of methane, CH4. This is a formula. Okay, now burnt. Okay, burnt with what? Air means which one? Here I am taking as a oxygen. Okay, oxygen, it is in a gaseous state, so that's why I am writing gas. Even methane, it is also in the gaseous state, so I am writing as a gas. Now what are the product? Okay, what are the product? Now a normal product you should write while writing the simple equation. A normal product. That means now whenever carbon, hydrogen, oxygen are present, whenever carbon, hydrogen, oxygen, whenever carbon, hydrogen, oxygen present, Now what are the normal product? As one is carbon dioxide, another one is water. This you have to remember. Okay, whenever carbon, hydrogen, oxygen present in the reactant side, okay, so normal products are carbon dioxide and water. So here I will write, that is carbon dioxide, CO2 plus water. Now carbon dioxide in the gaseous state, thus water either you can consider as a gaseous state, okay, or you can consider as a liquid state, okay, that is left to you, or based on the question asked, you can write, you can change this also, no problem. But here I have considered as a gaseous state. Now here, after writing the equation, you have to check whether it is balanced. Both the reactant side as well as a product side, number should be remains same. Atoms, number of atoms remains same. Okay, fine. Carbon, we'll check. Carbon, reactant side, then product side. Carbon 1 is present, here also 1. Now at present it is balanced. Hydrogen, okay, so 4, here 2, it is not balanced. So at present I am writing 2, adding 2, now it is balanced. Okay, now oxygen, here it is 2, but here how many? It is 2. Okay, here I will write the number 2, this one, and here it is how many? 2, here 1 oxygen atom is present, so 2 ones are 2. Okay, in between what is the number is it? Plus, so how many? It becomes 4 oxygen atom is present. 4 oxygen atom is present on a product side. Okay, so this 2 I will written here, so I have written plus sign. Then this actually it is 1 oxygen atom is present, but this number is there. This number is for entire water molecule. So 2 ones are 2. So here I have written, so 2 plus 2, it is a 4 oxygen atoms are present on product side. So here how many? So to become 4, how many more I should add? That is 2 more I should add. So it becomes 2 2s are 4. Like this you have to multiply. 2 2s are 4. Okay. Now it is balanced, but cross check again whether it is balanced or not. Carbon balanced, 1 atom is present on both the side. Hydrogen, here it is 4. Here 2 2s are 4. So balanced. Here oxygen, 2 2s are 4. Here 2 plus 2, 4. So 4. All the atoms of each element present. Balanced. Okay. It is the same. So this is a way of writing for the balanced chemical equation or combustion of methane. So based on this, you will get a few problems. Okay. Now the meaning I will tell you of this. Meaning I will tell you. If I want to find out mass, molecular mass of methane, how to calculate molecular mass of methane. Now methane, here I will calculate one by one. Okay, CH4. Now how many carbon atom is present? 1. Atomic mass is 12 plus how many hydrogen atom is present? 4 into 1. So 12 ones are 12 plus 4 ones are 4. What is the answer you will get? 16 gram. That means 16 gram of methane. 16 gram of methane plus. Okay. Oxygen. What is the molecular mass? How many oxygen atom is present? 2 oxygen atom. What is atomic mass? 16. So what is the answer you will get? 32. 32 gram. So here I will write 32 gram. That is only for this oxygen. But 2 is there, no? This 2 I will write here. So what is the answer you will get? 2 2s are 4, 2 3s are 6, 64 gram. Okay, in this 64 gram is present. Now I am moving to the next one, carbon dioxide. Okay, here carbon dioxide I will write. How many carbon is present? 1 into atomic mass is 12 plus oxygen, there are 2 oxygen atom into 16. So 12 plus this is 32. What is the answer you will get? 44 gram. So here 44 gram I will write plus water. Okay, so here only I will calculate water. Now H2O. Now how many hydrogen? 2. 2 into 1 atomic mass of hydrogen is 1. Oxygen 1 into 16. So 2 plus 16. What is the answer? It is 18 gram you will get. So 18 gram. But this 2 is there. So 2 into 18. What is the answer you will get? As 36 gram. Okay. So I will rewrite 16 gram of. So 16 gram of methane is reacted with 64 gram of oxygen to form 44 gram of carbon dioxide and 36 gram of water. I will repeat the meaning of this based on the molecular mass or weight. 16 gram of methane react with 64 gram of oxygen to form 44 gram of which one? Carbon dioxide and 36 gram of water. This is about gram relationship. Okay. Now if I want to write it in the form of mole, number of mole. If I want to write it in the form of number of mole. Okay. This I have put relationship with respect to gram or molecular mass. Now if I want to put a relationship with respect to moles, number of moles. Okay. Here is there a number? There is no number, but we have to consider as a 1. So that means 1 mole of methane. Okay. 1 mole of methane is reacted with how many mole? This number is given. 2 mole of oxygen reacted each other to form how many mole? Here number is not given. It is understood that 1 mole of carbon dioxide plus how many? 2 mole of water. Okay, that means I will repeat 1. Here number is not there, so it is considered as 1. Okay, it is 1 mole of methane react with 2 mole of oxygen to form 1 mole of carbon dioxide and 2 mole of water. Okay, so that means this I will erase. So I will correlate between mole and mass. Mole and mass. 1 mole of methane. 1 mole of methane means how many gram is present? Here, see 16 gram. Okay, so next 2 mole of oxygen means how many gram is present? 64 gram is present. Now 1 mole of carbon dioxide means 44 gram is present. So 2 mole of water means 2 mole of water means how many? It is 36 gram is present. I hope you understood the concept, the meaning of the entire balanced chemical equation. Based on this relationship, mole and mass, you have to calculate few problems. Now, the first problem, based on the stoichiometric concept, calculate the amount of water, so in which state is given? Gaseous state, produced by the combustion of 20 gram of methane. Okay, so what is a question is asked? Calculate the amount of water. Okay, so amount of water is asked to calculate. Amount of water is asked to calculate. Okay, with the help of water produced by the combustion of methane. Combustion of 20 gram of methane. Okay, so again here given as a combustion of 20 gram of methane. Okay, 20 gram of methane. What is the question? Question is asked about amount of water produced. Amount of water produced. Okay, so combustion of 20 gram of methane. Question is asked what is the amount of water. Okay, so first write the equation for this. Combustion of methane. So already I explained combustion of methane means it is nothing but burnt with the oxygen. Okay, so whenever carbon, hydrogen, oxygen elements are present, what are the normal product you should write? Carbon dioxide and water molecule, H2, carbon dioxide and H2. This you should keep it in your mind. Whenever carbon, hydrogen and oxygen is present as an element on reactant side, whenever carbon, hydrogen and oxygen present on a reactant side, then what are the normal product? Carbon dioxide and water. Okay, so oxygen, it is always in a gaseous state. Of course, carbon dioxide, it is always in a gaseous state. Water, it is given here. Water molecule, it is in the gaseous state. So I will write gaseous state. Okay, methane, of course, it is in the gaseous state. Okay, now equation I finished, but it is not balanced. How to balance? You have to cross check. Carbon, there are one atom on both the side. At present, it is balanced. Hydrogen, 4, here it is 2. So what I should do to balance? I will write 2, I will add 2 here. Now it is balanced, 2 2s are 4. Now oxygen, here 2 is present, here 2 plus 2 ones are 2 here. So 2 plus 2, how much? 4. So here I should add 2. So I will cross check. Carbon is 1, balanced. Hydrogen, 4, balanced. 2 2s are 4. Oxygen, 2 2s are 4. Here 2 plus 2, 4. So 4 oxygen atoms are present on both the sides. So it is balanced. Now this is a balanced chemical equation. Okay. Now what is the relationship is given? Gram relationship is given. According to the question, what is the gram information is given. 20 gram of methane, and here amount of water. How much amount of water is present? How much amount means it is nothing but a gram information. So I will write gram information. Now based on the equation, how many gram is present? Molecular mass you have to find out. That is already I have calculated and showed you. Okay, so 16 gram. 1 into 12 plus 4 into 1. So 16 gram. Here 2 into 32. Okay, that is 64 gram. Here I will write 16 gram. Here it is 44 gram of carbon dioxide. It is 2 into 18. So it is 36. So for 16 gram. Now I will put the relationship for methane and water. Why? Because according to the question, what is asked? Calculate the amount of water. So with respect to water, calculate the amount of water with respect to combustion of 20 gram of methane. That means mass of methane. Okay, mass of methane. So I will write it here. So mass of methane, okay, with respect to mass of methane, how much amount of water is formed? That means mass of water. This relationship I will put. Okay, so based on that, with respect to 16 gram, according to the equation, with respect to 16 gram, how many amount of water is formed? That is 36. This is fixed according to the equation. Okay, so with respect to 16 gram, if I use the 16 gram of methane, how many amount of water molecules are formed? What is the amount of water is formed? 36 gram of water is formed. Okay, but what is the question is asked? Combustion of 20 gram of methane. Combustion of 20 gram of methane. With respect to 20 gram of methane, with respect to 20 gram of methane, see, under mass of methane only I have written. With respect to 20 gram of methane, okay, how many amount of water is formed? What is the mass of water? I hope you understood. So this relationship I put based on the equation. So 16 gram of methane, if I use 16 gram of methane, how many amount of water will be produced? 36 gram of water will be produced. That is according to the equation I have written the data. Okay, but what question is asked? That is with respect to 20 gram of methane, what is the amount of water will be produced? Okay, with respect to 20 gram of methane, how many gram of what is the amount of water will be produced? Okay, so like this I have put the relationship. Now cross multiplication. So this you will be knowing. So which is asked? Mass of water is asked to calculate. So it is 20 into 36 divided by 16. Okay, so while simplifying, you will get the answer as 45 gram. So what is the mass of water with respect to 20 gram of methane, combustion of methane? Answer is 45 gram of water will be produced. I hope you understood the concept. Okay, next problem. See, how many mole of methane required to produce 22 gram of carbon dioxide after combustion? Understand the question properly. How many mole of methane required? That means the question is asked with respect to mole of methane. Question is asked with respect to mole of methane. How many mole of methane required to produce 22 gram of carbon dioxide after combustion? 22 gram of carbon dioxide. That means mole and mass relationship is given. Mole and mass relationship. Question is asked based on the mole and mass relationship. Okay. So again, it is nothing but this I will keep it aside question. It is nothing but a combustion of methane. So combustion of methane means how to write? CH4 methane. It is burnt with oxygen to form carbon dioxide and water. Now since it is oxygen is a gas, so G I will write. Here also gaseous state, and water it is not given according to the question, but I will write gaseous only. Okay. Now here it is not balanced, so you have to balance carbon, only one atoms are present, atom is present both the side, balanced. Hydrogen 4 present atom, so here only 2. So what I should do, it is again I have to add 2, so 2 2s are 4, it is balanced. Oxygen 2, here 2 plus 2 4, so here I will write 2, so it becomes 4. Now it is balanced. I hope you understood the understood how to balance. Okay, balance the equation. Now first I will write mass relationship. Based on this, 16 gram of methane react with 2 into 32, so 64 gram of oxygen, here 44 gram of carbon dioxide, here 2 into 18, so 36 gram of water is formed, produced. Okay. Now since question is asked based on the number of moles, so the mole information is also very important. So under this I will write mole information also. So that means here how many mole is used? That means here 1. So 1 mole of methane plus here this is 2 mole of oxygen. Okay, here 1. So 1 mole of carbon dioxide is formed plus 2 mole of water molecule is formed. So I hope you understood this. 1 mole of methane is used, or 1 mole of methane burnt with 2 mole of oxygen, 1 mole of carbon dioxide and 2 mole of water is formed. This is a mole relationship. Okay. So for me, based on the question, how many mole is asked? So I need mole of methane with respect to gram of carbon dioxide. That means what is the relationship I have to put? Mass of carbon dioxide. So based on the question, you have to put the relationship to calculate. Okay. So mole of methane, because mole of methane is asked with respect to 22 gram of carbon dioxide. So 22 gram means it is nothing but a mass of carbon dioxide. Now what is the information given in the equation? What is the information given in the equation? So mole of methane, okay, 16 gram. Okay, this 16 gram I don't want, so I wanted to write in the form of mole. 1 mole means how many gram is present? 16 gram of methane. So 1 mole, okay, 1 mole of methane gives how many mole of carbon dioxide? 1 mole. But this 1 mole I don't want. 1 mole means how many gram? It is a 44 gram. So 44 gram of carbon dioxide. For me, mass information is required with respect to carbon dioxide. So 1 mole of methane gives 44 gram of carbon dioxide. Okay. Now what is the question? How many mole of methane required to produce 22 gram of carbon dioxide? How many mole of methane required to produce 22 gram of carbon dioxide? So which is asked? Mole of methane is asked. So cross multiplication, 1 into 22 divided by 44. So what is the answer? 22 ones are 2 half or 0.5 mole. Okay, 0.5 mole. I hope you understood the concept.